When graphing rational functions, we've looked at vertical asymptotes and holes. They go together. They're from the denominator. And make a note of that. That's from the denominator. Horizontal asymptotes we can find from limits. Okay, or we can do this by long division, find the horizontal asymptote from the quotient. And the slant asymptote we get from the quotient of long division. Okay, so the slant asymptote is this, or sometimes called oblique asymptote, that line, the equation of the line, we find from the quotient of long division. So we're going to focus on looking for other points on graphs and finding zeros and y-intercept on a graph. And these are easy points to find, so we want to use these. So first of all, when we look at a function like this, we look at our restrictions. Our restrictions either give us a hole or an asymptote. So that doesn't cancel, so that's going to give us an asymptote. So when we look at that, I'm going to draw my asymptote in. When I look at this, I can find the horizontal asymptote using a limit. In the previous videos, we maybe did this by division and we use a quotient, but here I'm just going to use a limit. The limit as x goes to really big values. This is endpoint behavior. The -2's become insignificant, so we have a limit that equals 1. So that means that my horizontal asymptote ends up at y equals 1. Now, when I graph this, I can find some other points. And the points I'm going to use are the zeros and y-intercepts. So when we talk about a zero, we're talking about when y is 0, what is x? Well, we can find zeros from the numerator. If the numerator is equal to 0, then this whole function is equal to 0. So we can just say that when x is equal to 0, so when y is equal to 0, okay, so make this equal to 0, our x value to make this equal to 0 is going to be -3. So that coordinate is a point that we can get from the numerator. And I'm going to draw that in, so I have an x-intercept at -3. And that comes from the 0 in the numerator. Okay, so I'm just going to make this explicit. This comes from the numerator. Okay, so our asymptote comes from the denominator, our 0 comes from the numerator. The other coordinate we're going to use is the y-intercept. The y-intercept is when x is equal to 0. So when I plug in x is 0, I can just substitute x is 0 and calculate what's left over is 3 divided by -2. That's going to be -1.5. 0, 1.5 then represents, -1.5 represents my y-intercept, and I can then sketch my basic rational function through those points. Now, I don't have any points in the other quadrant, so if I want, I can make a table of values. I could do all sorts of things, but at this point, right now, we just want to have a general idea that it's in this quadrant, and it's relatively mirrored in that quadrant. So these are some new points we're going to look at, the y-intercept and 0, and this is just going to give us more coordinates based on starting with our asymptotes. The asymptotes are the most important part, but once we have the asymptotes, we can draw in our graph based on a few key points. And the key points we're looking at are the 0 from the numerator and the y-intercept when we substitute x equals 0.